Okay, let's pick up where we left off. And that was we'd made this sort of dynamic background that moves forward and left and right a number of instanced spike rectangle shapes. They all have a unique color that's being passed through a random, and then we have a bunch of other randomizing things up here that contribute to it making this unique pattern every time it's looked at. So that was, we made random positions for the X and the Z using a noise. We added that to the original TX, TY, and TZ for our shape from the line. We then also made random colors using a noise top that we viewed as a chop, and then combined that with a special noise to randomly generate some alpha values for our spikes, so that we get some that are transparent and pass in front of and behind each other, giving us just a bit more depth to our scene. All of that goes to a merge and into a DAT, and that DAT is passed into our instance that allows us to get our TX, TY, TZ and our RGBA for our different spikes as it moves. And with that done, we talked about we wanted to, the next section is we want to now add the noise or music reactive section in front of the camera. So something that sits between the camera lens and here that pulses and moves as noise happens. So what we're going to do is we're kind of going to create a whole separate section of all the work we've already done. We're going to make a new SOP chain going into a geo that goes to a different render using the same camera, and then we're going to combine our two images, so our render 1 and another render together, to allow us to overlay our two images. So the first thing we're going to do is we're going to come down here and we're going to create a SOP sphere. So I'm going to make a SOP, make a sphere, and I want to make this way more jagged. So I'm going to change its type to polygon, and I'm going to change its frequency down. 3 might not be low enough, so I'm going to change it to a mesh, and I'm going to lower its rows and columns as low as they can go. In this case, it will be 3. And that gives us this super spiky looking shape that used to be a sphere. It's essentially two pyramids stuck together. I'm then going to put that into a transform. So I'm going to right click, transform, and then I'm going to right click into a comp geometry. And it will automatically do all the connection of the wires we need so that our sphere shows inside of our geometry. So to do that again, it was right click on the transform, go to the comp tab and click geometry with it selected, and it will automatically connect the two for us with all the parts we need. If you ended up with a geometry that looks like a torus, remember, go inside of it, delete that torus, add the in SOP with the purple and blue dots enabled, and then connect it. Okay, with that there, what I want to do is I want to position this in a place where we can control it, where we can see it. So I'm going to go into my transform, and I'm going to move its Z value forward, so it's closer to the camera. So very clearly it's sitting between the camera and the background. But in our view, we can see it's way too big. So I'm going to transform this universe scale down. And I would say about there. So 0.4 on mine puts it at a nice size where it fits our screen but doesn't fill it. You can maybe go even smaller if you want to, like 1.2 or 1.25. And that gives us room to still grow it in any direction we want, depending on how we're going to interact with this. I then want to change how my scene is being rendered, just for practicality at this stage. And that is, I want to have one render for my background and one render for my shape that I can then combine together again. And the reason for this is that if I was to put alpha or a transparency to my front shape, I wouldn't be able to see these spikes behind it, regardless of their transparency. So I'm going to click on render 1, and inside geometry, instead of this star, which is a wildcard, I'm going to drag and drop geo 1, or whatever your geo is called that has your background in it, into the geometry layer. And that means we're telling Touchdesigner in this render to only see the one geometry we're linking it to. I'm going to come down back to my circle and do the same thing. I'm going to double click and make a new render top, and it will automatically capture everything in the scene from the main camera that's called Cam 1, all the geometry and all the lights. But instead of all the geometry, we want to just see geometry 2. And now our background has disappeared and our panel no longer shows our sphere. But we can combine the two back together. So in this chain between my first render and my output window, I'm going to right click and insert a composite. And if you've ever used Photoshop or After Effects or any visual editing program, the composite is how you layer images on top of each other. It'll give us an error because it says not enough sources, but now if I drag the chain from my second render into the comp, I now get a sort of visual effect of the two on top of each other. And that's because by default the composite is set to multiply, but we want to set it to be over, and I want to put render 2 above render 1. So I'm going to do that by pushing this little blue arrow. And now everything looks the exact same as it did before, but render 2 and render 1 are now being taken from different places, or our foreground shape and our background shape are being taken from different places. And it just means that we can now apply transparency to our foreground shape and it'll translate onto the background. So we'll see our spikes through our sphere. Okay, brilliant. With that out of the way, we want to make our sphere a bit more appealing. So the first thing I'm going to do is I'm going to double click and add a constant. And I'm going to add that constant matte as the material. So just like we learned before. I'm going to make its color something a bit more attractive. So I'm going to go to this burnt orange. I'm going to change the alpha down and go to the common tab and turn on blending and transparency. So click on the constant, common and blending on tab. Lower the alpha a bit. And we can see already what I was talking about, that we can actually see the spikes through our shape now, thanks to that composite. And we can also see the other edges of our sphere, thanks to the blending that we just enabled. So set that to a value that you're happy with for now. And I'm going to show you a fancy way that we can create two versions of this geometry that have two different textures that react in different ways. So what I'm going to do is I'm going to select my geometry and I'm going to literally Control-C, Control-V or Command-C, Command-V to paste it. And now I have a second version of the exact same geometry. And I'm going to parent these two together. So rather than going left to right, I'm going to select this bottom one, this bottom outlet of Geo2 and connect it to the top of Geo1. And now if I was to make a second constant on my Geo3, change its color, and then I was to tell the renderer to see this. So I don't want to just see Geo2, I also want to see Geo3. So I'm going to select the renderer, and then where it says geometry, I'm going to type Geo2 and the name of this one, which is Geo3, in there with a space between them. And I'm telling it to basically see this one and that one specifically. I can now move one of these shapes to the right. So I have one version and another version. And you can see I moved the childed version, so the one that was connected into the top, to the right. But if I now move the parent to the left, up or down, back and forward, the child comes with it. And that's important. So it means that I can make two versions of the same shape that have two different texture styles, two different forms, anything. And it means that I can guarantee they're going to be in the same space. So if I transform one, it will transform the other. So I'm just going to Control Z until they are back on top of each other. And I'm going to change my second shape from being a constant. I'm going to go into the Deform tab, or the Common tab, sorry, and come all the way down to where it says Wireframe. I'm going to turn that to On. If you're using a Mac, you'll have different options in here, but just drop down the wireframe and click anything that works. I'm then going to make my line width slightly bigger. But thanks to the blending transparency that both of our shapes now have, I can see the red wireframe, you can change the color if you want in the Common tab, the wireframe outline of my shape and the main shape itself in the same space. And if I make a change to the scale, rotation, or position of either of my shapes, it applies to both thanks to the parenting tools that we implemented. So again, it doesn't really matter if you don't understand what's happening or why that's happening, but Geo2 is now a controller for Geo3, no matter what Geo3 looks like. If I make the change to Geo2, it will apply to Geo3 as well. So we can start to do fun things like changing the scale without worrying about whether it's going to update on both of them. And it means that I can get these unique double effects layers down here. Okay, so I've got my shape. It's a circle or a sphere that we turned into be tiny. We then put it into a transform and scaled it all the way down into two identical geos that are parented together with this top and bottom connection into a unique render that signifies only see Geo2 and Geo3, and then connect it into our main pipeline using a comp over, and then we have our final output that's currently going to our panel. So we are almost there with something that is usable. All I need to do now is bring in audio and analyze that audio file to work out whether it's a beat or it's a kick or anything that you want to do with it. So Touchdesigner supports dragging and dropping. If you find a file, drag and drop it into Touchdesigner, whether it's a photo, a video, a movie, GIFs, audio, it will just start playing it for you. It will automatically analyze whether it needs to be a chop or a top. But I would recommend you against doing this with audio because it will automatically start playing and it can be deafeningly loud. So I want you to find a file inside your computer, and so I want you to double click and add a chop audio file in. And by default, it'll start loading a Touchdesigner's default sound, but we won't be able to hear it. Because not only do we need to tell it to load a file, but we also need to tell it to load a player. So if I was to double click and add an audio device out, I'm going to turn the sound way down. I'm going to plug the two into each other. So what we should now be hearing is some music from Touchdesigner that is its default file. But I have another music file that I want to use, so I'm going to find the reference for it. I'm going to find its file, and then just going to load it in here. If you're having issues, literally just drag and drop your music file in. So I'm going to pick a music file that I know is fairly bassy. This is a dance music file. It's meant for mixing, so it has a super long lead in and a super long lead out. But hopefully, as you can hear, it has quite a lot of bass kicks in it. I'm going to bypass, by pushing that little arrow, the audio device out. And that means that I'm going to stop being able to hear it, but the audio is still playing inside Touchdesigner. If you want, you can leave this on a super low volume and leave it running just so you can still hear what's going on. But while I'm talking to you, it's impossible for me to work and hear at the same time, but I know what I need to add to make this patch. I need to look at this audio, turn what is two stereo tracks, a left and a right channel, into one channel, and then analyze it for when I think that there's a high bass note. So I'm going to double click and add a math chop and connect my audio into it. The first thing I'm going to do is I'm going to combine channels by average. And that's going to turn my two audio tracks into a single combined audio track that is the average between the two. Most music, when it's mixed, will have similar channels on the left and the right. Some may wildly vary. Using an average means that we're guaranteed to get the right, a good sample of both channels. So now we've combined our channels, what we want to do is we want to look at them and apply an audio filter that only lets the low notes come through. So bass notes and kicks are stereotypically low. So I'm going to right click and I'm going to add a audio filter chop. And I'm going to leave it on a low pass because I want low sounds to pass through. And then I'm sure you'll appreciate it's still very hard to actually look at this and know what that means in terms of data. So we're going to right click and add an analyze, and we're going to look for something called the RMS power from this drop down. And this is basically going to get the overall oomph of the music that is passing through the low pass. To make sure that it's only passing through the right amount of data, I don't want to go too much into audio analysis and what this means, but look at your audio filter again and change its cutoff units from logarithmic to frequency. And what we're going to do with this is we're basically going to say anything above a certain value, cut it off. Anything below a certain value, let it pass through. And to visualize that for you, you don't need to worry about this. I'm going to add 2 audio spectrums, one before the filter and one after the filter. And this shows the audio sample that is currently coming from the average and the audio sample going through our filter. I'm then going to look at my audio filter and lower its cutoff to about 180 Hertz. So with our frequency cutoff at around 180 Hertz, we see that we've lost literally everything on the right hand side of our sample. That means all of the garbage noise. And when we look at the RMS power, it means that we're getting essentially the average oomph over the sample at that time. We want to put it into a bit more of a logical view for us. So we're going to right click and we're going to add a math. And I'm going to double click this and rename it to threshold. That's just for my personal knowing, so that if I ever need to come back to it, I can refer to it. And I'm going to leave that as it is for now, but it means that later on I can come and tweak the value of the audio if I need to. And then from our threshold, we want to go into a limit. We're going to say limit clamp of between 0 and 100. So we're basically going to only let a value that is between 0 and 100 pass through here, just in case we get some crazy sound spikes. We'd never want it to be negative, otherwise that could break our whole system. And then from there, we're going to go to a logic. And that logic is going to be as default, which is off when 0 or less. And now we need to go back to our threshold and tweak it so that when we hear a spike, or when there is a spike, the limit triggers, otherwise it's off. So the goal of our threshold is to make the average noise when there's not a kick be less than 0 and everything else be over 0. So I'm going to reduce this, and we can see the more I reduce it, the more it starts to flicker. I am going to need to listen to my audio just so I can hear this. And already I'm starting to get a picture of when there's a really big kick. My logic and my thresholds are limiting what comes through. So 0.5 is good, but I can probably tweak that a bit more so it doesn't have a double trigger. So with a threshold value of about negative 0.55, I can hear when my music plays a bass kick every 4 feet, I get a value of 1 come through. It doesn't matter how long this is on or off for, we can use that to control almost anything we want inside of our scene. Now that the song's in a steady build, I'm happy with that threshold, so I'm going to bypass my audio device out so I can't hear it. Again, you're welcome to always have this on while you're working. Now, I have a logic value I'm going to pass to a null, and then I'm going to signify that this is important. So I'm going to push C on my keyboard. That'll bring up this color palette, and I'm going to color this null red. You can color it whatever you want, just so you know it's special. So now when I zoom out, I can see this is bright red. I know that this is where the trigger value for all of my work is going to come from. Okay, so now that I have what we could call a trigger value or a conditional of sort, we can use this to generate a lot of things. But rather than 0 and 1, I wanted to do more. So the first thing I want to do is I want to make it a color. So I'm going to make a constant top that feeds the color of my actual constant here. So I'm going to double click and add a constant top. Now the way the constant top works is it has an R, a G, and a B that range between 0 and 1 and give it a red, a green, and a blue value. I want to use this 1 that I'm getting every pulse off the kick to generate a new color. And to do that, I'm going to need an expression. So I'm going to say, what I'm going to do is I'm going to add a noise. I'm going to give it 3 channels. I'm going to give it R, G, and B, again by going to the channel tab and doing R space G space B. And I only need 1 value. So rather than worrying about this start and end point, I'm going to go to the Common tab and enable this time slice function. And that's basically going to take rather than showing us all the values left right, it's just going to sample 1 value for us as we see it. Now I want to, every time that this triggers, I want to capture all of these values and use them to drive the color in my constant. So the first thing I'm going to do is I'm going to add a math, and I'm going to go to the post operator and turn them positive, because I always need a value between 0 and 1. I'm then going to right click and add a constant. Now we've previously used a constant to make values, like when we first looked at it, we can drag and create values here. But a constant also has this page called snap, and it allows us to snapshot inputs from whatever's being passed into it. In this case, our noises with R, G, and B. If I snap, it's going to take a picture at that time whenever I push this button. So I want to push the drop down on snapshot input, and I'm going to reference null2 in this value. 1 means push, 0 means off. So I'm going to activate my viewer, highlight the channel, and drag and drop it in there, relative chop reference. So now every time that a pulse is heard and it goes through our analysis chain, it's then going to take a snapshot of these random noise, and give us a color. In my noise, I'm going to go to the type and change it to be actually random, just so that we get a much crazier number, and it has the potential of being 1. When it's sparse, it's a different type of generator, but that doesn't really matter for now. I'm then going to send that to a null, and in the same method, I'm going to activate the viewer and send the R to the constants R, the G to the constants G, and the B to the constants B. So now I have a color that randomly generates every single time a pulse is heard. I'm going to reset my color to be white in my main constant and drag and drop this onto it. And as we learned from the before, it gives it the color that we just layered on top of it. So now I still have my wireframe on my second geo, but my first one is now using a constant to color its transparent background. Simple as that. So to recap that stage, it was bring in your audio file, whatever that may be, add it to a math that then combines the channel by average. So that turns it from being a stereo track into a mono. We're then going to filter that audio using a low pass with about 180 Hz cutoff. And that means we go from a noisy track like this to just seeing the left-hand lower end of the audio sample. We're then going to analyze it using something called RMS power. We're then going to pass that to a threshold that is a math that basically has a negative 0.5 addition to the value, a limit that lets it only be 0 between a 0 and 100, so we can't see negative numbers. And then we use a logic chop that says whenever this goes over 0, then turn on, otherwise be off. And we get this 1 and 0 flickering number. Every time that flickers, it snapshots a random number between -1 and 1, turns it into a positive, so between 0 and 1, and uses that to drive the color of our shape. So with our color changing started, and I'm pretty happy with that if I listen to it. Okay, I think that looks good. I also want to adjust the look of my shape. So I'm going to repeat this random number generator, and I'm going to make it control the scale in 3 dimensions. So the X, the Y, and the Z scale of my transform here. So I'm going to reset that back to 0. Oh no, I'm not. I want that to be like that. And I'm going to insert another transform after it. So sphere 1 into transform 2 into transform 3, and in here I'm going to adjust the scaling on all three of these every time we hear a beat using a random number. So I'm going to use the same trick. I'm going to add a noise. I'm going to give it 3 channels that are X, Y, and Z. I'm going to time slice it because I only want to see that. And I'm fairly happy with sparse because I don't want to have the same craziness that this has up here. I am going to add a math again to normalize it, so bring it into a positive number by combining channel post operator positive. I'm then going to go into a constant that then uses a snapshot. So I'm going to go to the snap tab, drop down the snapshot, activate my null 2, drag and drop it in, and relative chop reference. So now every time there's a beat, it's going to take a new snapshot. But I want to do something more with these values. So the first thing I want to do is, by default, my scale is already 1. So I don't want my value to be between 0 and 1. I'm going to use my math to change that to be between 0 and 2, or 0.5 and 2. Which means we should get much more drastic movements in our shape. After my constant, I'm going to right click and add something called a filter chop. And this has the really nice effect of slowly ramping between 2 different movements. And I'm just wondering if it's going to create the effect we want. It might be too aggressive for now. So I'm going to bypass the filter and I'm going to add it to a null. And then I'm going to reference this null in this transform. So I'm going to make sure my transform selected, come down to the null, activate it, and drag and drop these onto my scales, X, Y, and Z. Okay, so I think I actually like that, the way that the pulse is happening. I do want to change my math slightly more, so I think I want it to range from 1 to 2, just so it has this nice starting size and then it gets bigger. So the values are randomly generated between 1 and 2, and they're all positive, rather than between 0.5 and 2. So it has this chance that it comes out of the screen, but I also kind of like that and the effect that it's creating. I think one of the last things we want to do is add some sort of craziness to the rotation. And I think I am going to filter this one. So I'm going to make yet another noise, give it 3 channels. I'm going to call it RX, RY, RZ. I'm actually going to need to make a quick change to the way that our shape is built here. When I translated it by 2.7 here, I'm going to remove that. I'm going to say 0, and I'm going to move the whole geometry forward by 2.7 instead. So I removed it from my transform and applied it to the geometry. And that means that it now doesn't adjust as drastically, but the reason for that is that the pivot point of our shape had changed, which was causing crazy things with scale. So remove the transform value from Z in our SOP chain and apply it to our geometry chain. And that's just going to make this next section much easier. Okay, I've added a noise. I've called it RX, RY, RZ. I'm going to time slice. I'm going to go into a math that operator is positive. I'm then going to go into another math that changes the range between 0 and 1 and 0 and 360, because there's 360 degrees. I'm then going to go into a constant that has a snapshot from null, so it's still active. Drag and drop it over, reference. And I'm going to go into a lag. And what's going to happen here is a lag slows down the value coming into it by delaying how long it appears. And then it ramps between the values that it has based on how long it's delayed by. So we want our shape to instantly move to its new location. But then we want it to slowly ramp if it's going back to the original. So I'm going to set lag of the up slope to 0 and lag of the down slope to 2. And if we now apply this to our geometry rotation, so I'm going to do it on the geometry just because this can be slightly CPU intensive. So we want to place it all into the graphics card, and I'm going to do rotate X, rotate Y, and rotate Z. I might add the 0.2 rotation back in, or lag back in, just to see what it looks like. And I think I want to change my scale so it's crazier. So I'm going to come over to my math and change my 2 range to be 3, maybe 5. There we go. So now my random scaling is really big, and every time there's a beat, it also rotates. And if we listen to it, so again, I'm pretty happy with that. The track is either at the start or at the end, but it's still really nicely triggering every time there's a beat. Your results may vary based on how you've implemented your thresholds and stuff, but as long as you can get it to trigger on some sort of audio, I'm more than okay with that. Every time there's a beat, changes color, rotates it, and it changes its scale. Okay, so I'm going to save it there. And I'm going to say that this is basically the limit for what will pass this project. On the rubric, this will fill enough points that you will more than pass. So this will be worth at least 11 out of the 15% available, so that it's worth a 70% on the overall project grade. Next, we're going to add some stuff that encourages creativity and playing around. So the first is, I want you to explore using different shapes. So we used a sphere, but there's things like a torus, a tube, a box that we already learned about, a circle, which is kind of like a 2D sphere. We have a rectangle that is a 2D box. So there's lots of shapes that we can play about with. And with our system, we could just plug them in and they'll do lots of different things. But we could also, is that a quiet part of the song? And after we've plugged that in, we could play about with the shapes and sizes of the parameters of our shapes to start creating fun experiences based on what we're seeing. We can change the way that they're made. So like a polygon torus has these much nicer straight lattice look rather than the original mesh look that's all connected. We have tube that is open in the middle. It's kind of like a 2D torus. We can change how many rows and columns it has to make it a much more jagged shape. I can also, if I go back to my original sphere, between my output and my transform, if I right click and add a noise for SOPs does a really nice movement and transform, where if we slow it down to say 100, what it's going to do is it's still going to respond to all the movements we've got, but it now means it's creating a more random shape by default. So the noise is applying to all the vertices and points of that 3D shape, the same way that the noise randomly creates 3 numbers for us every time that we use it in this way down here. So for extra marks, I want you to explore with the type of shape that you have plugged in, and you are going to be playing with the parameters that it has to make a much more unique, fun shape by default. The next is I want you to play about with the color of your shape. So down here, we made a constant that takes this random color here. But what happens if rather than using a randomizer, we build something like the ramp and connect it to an LFO, the same way we did at the very start of the very first video. Connect the ramp into the phase of this. and then use that as the color for it instead. You could even connect the pulse of this. So if I take the null out into a filter, it will ramp up and down between 0 and 1 based on the pulses coming from this. So the shorter the width, the smoother the quicker the change, but it's still a smooth ramp. You could use that to drive something like the alpha of your shape, so it's invisible or it's not visible. I also want you to play about with what we did with our background in the first scene. So I want you to see if you can make it faster. I want you to see if you can make the colors more exciting, whether that be using a different noise generation or a different way of creating color. It really doesn't matter what you do. I just want you to explore with adding things into Touchdesigner or playing about with what we have added. So I would change the color of, I would change this noise. I'd change the type of noise to be like random, or alligator is normally really quite exciting. What happens if it's monochrome or not monochrome? What sort of effect does it create that you like? And then for the final thing, I would see if you can change the style of background that you're creating. So in this, we have a line that generates 90 different versions of a box that we stretched. But what happens if we introduced something like a sphere to our background and made it scale tiny? So the sphere in this case has a scale of 1 on the Z, so it's still quite big. And it's also still quite tall. But can you start making different effects if you were to introduce the Y back into our maths? So if I added a TY, suddenly it's going to start moving these little balls up and down, left and right, and back and forward, as well as just our shapes up and down. So those are what I want you to explore with. I want you to explore with changing the shape for a different style, change around with the parameters that we added, maybe add the noise to this chain, and see if you can create a nicer effect than just the sphere that pulses when the music kicks. I then want you to explore if you can make the color of our shape more exciting, like whether you use a ramp that has an LFO driving it, or you use a noise to make random colors again, like we did up here for our background. I also want you to explore changing the colors of our background. So again, sampling or playing about with the noise parameters. What you can do, is there something else you could add here? What happens if we added a ramp into this chain? What sort of things does that do to our vision? And then I want you to play about with the idea of using a different shape. So probably the most advanced thing here is using a different shape in the background. I used sphere as my example. And then seeing if you can introduce movement on the Z axis, so up and down, as well as forward, back, left and right, in our noise position. So up, top, left, that's my clue for you. Channel, add a TY, and then see what effect you can create using that as well. Can you create some sort of like star effect? Can you create flying boxes? It doesn't really matter what you do, as long as you just get creative and start playing around with Touchdesigner. As with all of these throughout, I am available for you to email. I hold time in my office most days downstairs in the Fine Arts Co-op, and your instructor should be able to help you a little bit while you're going through this. If you feel like your laptop isn't good enough, or you want more power to play about with more advanced topics, your AET student card should give you access to the Play Lab that I shared the map for at the very start of the first video. So now the final thing to do is there's something called performance mode. If you push F1, you can push escape to get back out of it, but now you can push F1, go into performance mode, listen to your song, and watch your masterpiece at work. I look forward to see what you create with this.